Welcome to the Assured Expert Interview series, in which we are talking about the future of security in next-generation smart connectivity systems. I'm Valentin Popescu from Martel Innovate, and today I have with me Stylianos Basagiannis from Collins Aerospace, the partner in charge of smart aerospace aircraft device use case. Stylianos, thank you for joining.
Thank you for having me, Valentin. Great to have this discussion today.
I would like to start, and my first question would be, can you explain what is the most urgent problem in cybersecurity research that you are trying to solve in Assured?
Sure. Well, when we first joined Assured with the ideas of applying, let's say, new cybersecurity mechanisms for the aerospace sector, it was fitting really nicely with the most recent aircraft initiatives. Aerospace sector is moving to more connected, more integrated systems nowadays. And if you see the whole evolution of Internet of Things, of AI, of more smart systems entering our aerospace ecosystem, it is important to incorporate new security mechanisms at design time and at runtime in order to assure the correct, safe and secure operation of cyber-physical systems. So this is what Assured is bringing to us, new technologies like security attestation, or let's say policy enforcement mechanism from a security point of view, in order for our engineers to be able to follow a much more sound methodological way to secure their systems in aerospace.
You are driving the integration of Assured security solution in a safety critical application domain as the secure aerospace. Can you please summarize the core challenges, for instance, trade-offs between security versus safety, security versus trust, security versus usability, how all these are being taken into consideration?
Sure. You have to understand that the aerospace sector is it has to bring cross-domain solutions that have to take into account what we so-called interdependable requirements. This means that you care about safety of the aircraft, but you also care about security of the communications of the aircraft, or you care about security and performance of certain, let's say, systems. So all of these interdependable requirements bringing different, let's say, different nature of requirements from an engineering point of view, it is really a challenge for all of the engineers to follow the same, let's say, information across the whole product life cycle. So, for example, when a safety engineer and the security engineer are developing solutions for the same product, they have to have some means of communication. And these model artifacts that they are building to evaluate their prototypes, they need to be developed in a common setup, in a common setting, right? So and this is because we would like the decision-making points from some of the critical, let's say, design parameters of our systems, we like to be as much collaborative as possible. And this is the analysis trade-offs that we are trying to do. For example, if you try to build a much more secure, let's say, module, try to see what would be the impact with respect to delays or latencies when you pretty much execute some critical operations. And that was one of the main, let's say, use case parameters or use case scenarios that we would like to evaluate with Assured to tackle this situation, or try to flow the engineering information from a security and safety point of view, bringing, for example, risk assessment methodologies during the design life cycle of the product in order to include some security constraints when we try to design a safe system for the aircraft.
Mm-hmm. Security is not a standalone problem in avionics, as in most of today's autonomous systems. And this desire to have aircrafts to be more efficient, more secure, and cheaper has driven trends across the industry towards concepts such as remote maintenance. What does this entail, and how Assured Trusted Computing helps towards this direction?
Well, this is a panacea in pretty much the next generation embedded systems that we see, not only on the aerospace sector, but also in the automotive, on smart cities, healthcare system, and so on. There is the need for a trusted-based computing solution or a root of trust that serves, let's say, in a sound way, all of the security operations that an embedded device will execute. It is really important for Assured to try to form its technology across those lines. And I could say that Assured was quite successful when incorporated a real-time operating system trying to support and the control flow attestation mechanism together with some tracing capabilities in order to extract information on these low-level embedded operations to provide assurances for some of the most known attacks that we have to face. For example, during remote updates, when you would like, for example, through satellite connections, when you try pretty much to update your firmware of a remote device, you can understand that this operation is very, very critical because you don't want malicious code to be executed on your aircraft or on your car, for example. Thus, there is a need for a secure channel, for a secure attestation mechanism embedded within the low-level primitives that each device will execute in order to move forward successfully with a firmware, let's say, update. And I think Assured has done this pretty nice with respect to the solution that is offering, and we're quite happy to see results about it.
Could you explain us the philosophy behind integrated trusted computing attestation services, and how can CFA help overcome any security challenges in the supply chain of the aerospace industry?
Yes, it is also as we discussed in the beginning, right? When you see the aircraft ecosystem evolving, right, that bringing much more resources in order to help the airlines solve complex challenges. For example, you try to extract as much data or bring as much data as you can in order to make better decision-making processes with respect to maintenance, with respect to the supply chain, that it will trigger, for example, your parts for the aircraft for a required maintenance to be transferred in a timely manner to the location that the aircraft will be. This will accelerate the supply chain. This will accelerate the aircraft to be again at an operation point of view. But all of these data exchange, all of this communication, all of these data storage, which can trigger critical supply chain operations, it is a part that we see security to be really important. If someone will let's say violate or pretty much malform this type of data, then the wrong decision will be made, and so on. So attestations, it's not only a service, or we don't see attestation, control flow attestation as a solution just to make sure that the correct, let's say, maintenance or the correct piece of data will self-authenticate itself. It is also in a much more global picture that when we try to merge systems, hardware at the system level and at the edge, it is a solution that will enable us protecting data from its source when the data is exchanged and when the data is stored. And this is how I see it being a really important technology solution for the transportation domain.
How is it that you are conducting your tests? Are you using some actual hardware, trying to emulate real-world application as much as possible?
Yes, well, testing is a major engineering phase in all of our systems and our products' life cycles, right? So if you consider that we are talking about cyber physical systems, verification, analysis and testing, all of these different phases, there is an engineer behind it that is going to spend time making sure that system requirements are being met, customer requirements are being met, and more importantly, certification guarantees can be extracted by those systems. Safety critical systems have to obey several certification objectives and needs to pass several certification checks in order to be sold commercially and fly up in the air. So we have a series of engineers, we have a series of tools that we are using with respect to testing. You can consider it in using classical simulations, moving to formal verification techniques like model checking, and also SAT-based constraint solving and optimization, automation of testing using some of the commercial tools, but also in-house tools. All of these techniques, they are part of our day-to-day engineering work. Well, depending on the application, you might consider also software in the loop or hardware in the loop testing. So there is specialized hardware that can be used from a testing point of view.
Besides the obvious technical advancements, how else can Assure impact the aerospace industry in terms of type of research that you are doing?
I think and based on the technology that Assure has employed so far, right? The aerospace sector and most of the critical cyber physical system is depending on a multidisciplinary setting, right? There are lots of different engineers collaborating with each other. As we discussed, a safety engineer, a security engineer. I can add to them an embedded systems engineer, a systems engineer. So all of these people need to have upfront or as soon as possible information regarding artifacts, regarding models that each of the engineer is working on. So the constituent pieces of the system, whether this is a safety processor, whether this is a crypto processor, we are talking about the same system. This means that information needs to flow in all of these engineers. I believe one of the interesting technologies that Assure has brought in is the policy recommendation and enforcement feature. So if there are constraints, different constraints within our engineering, let's say, team, then new policies could be formed respecting additional, let's say, constraints, additional rules that the engineer needs to impose into his designs. And this knowledge needs to be across the whole product life cycle, especially for interdependable requirements, as we were discussing, like for safety, security, and performance of the system.
So looking at this project so far, what kind of challenges have you faced with Assured?
Well, Assured is an R&D project, right? And all of these R&D projects, when we are exploring new technology, it has a challenge when we are looking into the real devices, right? So picking up the technologies from Assured, like security attestation, or the tracer capability, or the policy enforcement mechanism, when you are talking about the real device, the integration, application of these technologies into the real hardware, it always has challenges. Some of the solutions might be developed in a much more agnostic manner or in a much more academic setup. We need to tune these software libraries, this code, to make sure that it's working on the real devices. And this is not only a problem for Assure, this is a problem for the majority of the R&D projects when we are looking from theory and from some, let's say, low TRL level solutions. When we try to import or pretty much introduce these solutions into our devices, you will always need some engineering time, some engineering cost to figure out how everything will be glued together. So I think this was the biggest challenge, from turning some technologies that they are, let's say, platform agnostic, to be much more specific in order to showcase the value of the technology into our own platforms.
Are there any strategic exploitation avenues that you are targeting after the end of Assured for the proposed solution?
Sure. Even internally in Collins, we've already have reached out to our business units with respect to security solutions that Assured is bringing up in front. I think for us, even now, we are participating into conferences, trying to disseminate the work of Assured, either through publications or industrial presentations that our team is giving to industrial forum. I think one of the good exploitation strategy is Assured technology should not end up until the project is ending. Assured has to continue evolving, providing leverage the technology to new European projects or new initiatives that can build on top of Assured. And this is what I think it could be. It could help mature the technology much more, and we could pretty much leverage all of the security solutions in a more, let's say, collaborative manner within the European, but also the international, let's say, context.
And one final question. From your perspective and your company's perspective as one of the key players in avionics research, what does success for Assured look like for you?
So I think Assured already has demonstrated the security solutions as part of a use case scenario, of an aerospace use case scenario for us, and as well for other use cases that has been demonstrated as part of the Assured project. I think success is a multi-parameter, let's say outcome that it depends on a lot of parameters, right? I think the first one is maintaining and maturing the technology while we widespread the outcome of Assured. It will raise awareness, it will increase visibility of the technology results that Assured has. And especially on a cybersecurity setting when multiple stakeholders, even if they are not security experts, they are part of the system. This means that they need to increase the cybersecurity awareness, especially during the design cycle, during their development tasks of constituent parts of the system. So I think raising the awareness, showcasing that the technology has worked, and try to influence as much as we can. This is the success. This is a success, at least what I think it would be a success for Assured project.
Thank you very much, Stelios, for your time.
Thank you, Valentin.